Okay, so all of the things we've been doing so far with functions, we also need to be able to do with functions that contain logarithms and exponentials. Okay, so this goes on from both looking at domains, ranges, as well as finding composite functions. Okay, so we're going to do a couple. So first, if we have the function f of x is equal to 2 to the power of x plus 3, and we've been asked to find the range. So what is the range? So what is this function's range? Right? So to start off with, it's best to sketch the function. Okay, so we've done loads and loads of sketching functions in chapter 3. So like looking at functions, we've done that, like we've done loads and loads of it. So if we kind of think of this here. So if we have an exponential, we start with the position 0, 1, and we start with 1, a, and a is the x, like the base of the exponential. So we would have the points 0, 1 and 1, 2. But what we've done is we've got that plus 3, so we know we've moved it up 3, and that's the y, so we're going to have 0, 4, and we're going to have 1, 6. So if we draw this, we know we're going to have a function that looks kind of like this. That one would be 4, and we're going to have a point 1, 6, right? We also know normally with an exponential it doesn't go into the negative y values, and we would have an asymptote, and that's how far we've moved it up. So that asymptote is going to be y equals 3. And we've got our x and our y-axis, okay? So therefore we can say that the range, we know, the range of this function, so like the output of this function only exists, like the only outputs that exist are greater than 3. So we can say for the range that y is a member of the real numbers. That's not the really important bit. The important bit is this next bit, which is just that y is greater than 3. So that's the range for that function. So that we can do with both logarithmics and exponentials. So we'll do one for an logarithmic function. So state any restrictions on the domain. So we're looking at domain this time, not range. And remember, domain is to do with the numbers that we can put into our function. Range is the numbers we get out of our function. We're going to do f of x equals log to the base 6 of x plus 2. Okay, so again, starting to think about kind of, we're going to draw that function eventually to give us some idea of what's going on. With our logarithms, we know we have 1, 0, and then we've got the other function, which is a1. So a is the base of our logarithm, so we're going to have 6 and 1. What's happened with that minus 2 in our bracket with that logarithm is that our logarithm has been moved to the left 2, because remember it does the opposite, so we take 2 away from our x values, so we get minus 1, 0, and we have got 4, 1. Give me a second there while I take 2 away from 6, but we get there, right? Okay, so we've got minus 1, 0, and we should have something that's 4, 1 somewhere over here, and we can draw our logarithm that goes roughly through those points. Make that point a bit bigger, right? And again, we have an asymptote here, so we know that for this, our asymptote, we moved our x values back 2, and our asymptote was the y-axis, and it's now been moved back 2 to go to x equals minus 2. So we can say for this one, the domain, that x is a member of the real numbers. Again, don't fuss too much about that bit. the important bit is that x has got to be greater than minus 2. Because there's no, like, if you put a number less than minus 2 in, even if it's minus 2.001, you're going to get an error. So this is like what inputs will give us an error as an output, is looking at the range in the domain. Okay, so we're going to go on and do like a couple of examples with composite functions using logarithms, and then that'll be the end of this before we move on to vectors. Right, so what can happen with composite functions using logarithms and exponentials? You can get given, so far all the ones we did were linear, or they were algebraic, just completely like that. They had no logarithms, no exponentials, really. Well, we had some things to like squared, but we didn't have any kind of higher exponentials. Right, so we have here f of x equals log to the base 3 of x, and g of x equals 9x to the power 4, and we're wanting to find f of g of x, which will be h of x. Okay, so we want to find h of x, which is f of g of x. So that means that we're putting g of x into the function f. So into the function of f of x, we're putting 9x to the power of 4. Okay, so that means we've got log to the base 3, and then where our x is, we put in that g of x function. So we get 9x to the power of 4. Okay, so now remembering back to our logarithm rules, just because we've not done that chapter in a while, it's been a while, doesn't mean we can forget it all. So when we've got things that are multiplied, we can split these up. So we're going to get log to the base 3 of 9. Because they're multiplied, it becomes plus log to the base 3 of x to the power of 4. 9 we can think of as 3 squared. So we have log to the base 3 of 3 squared. Plus log to the base 3 of x to the power of 4. Just do that in one step. And then both these powers can come down the front. Happens for both of them. So we're going to get 2 log to the base 3 of 3 plus 4 log to the base 3 of x. Okay, so log to the base 3 of 3 is just 1, so we get 2. And plus 4 log to the base 3 of x, nothing else we can do there, so we just leave it as it is. Okay, and if you're struggling there with those logarithm rules, probably best to go back and watch some of the logarithm videos again. Make sure that you're brushing up on these kind of semi-regularly so we're not forgetting. Okay, and that is us for the functions section. And our next topic, which is 1.4, outcome 1.4 of Unit 1, is looking onto vectors.